After the session, we are going to learn Newton's first law and use it in the following situations. Where the resultant force on a body is zero and the body is moving at a constant velocity or is at rest. Another situation where the resultant force is not zero, the speed or direction of the body changes. Speed or direction includes acceleration. So let us quickly understand key terms involved in this topic. First is a resultant force, another is balanced force. Next one is unbalanced force, another one is acceleration. So let us quickly understand one by one. The resultant force, when two forces act in the opposite direction, a resultant force can be calculated as the difference of two forces. The direction of the resultant force is in the direction of larger force. Let us see the situation. Here you can see that one force of magnitude 35 Newton is acting towards right. Another force is acting towards left, and the magnitude of the force is 25 Newton. Now, you see here the two forces are acting in the opposite direction. The resultant force here can be calculated as F1 minus F2. And because the resultant force is not zero, the body is in motion, is in accelerated motion. Now look at this. F1 minus F2, that is 35 minus 25 equals 10 Newton. Now let us talk about balanced force. When two forces act in the opposite direction and their resultant force is zero, is called balanced force. Here you can see that the body is not moving. Two forces of equal magnitude, each one has got magnitude 25 Newton. From left side and from right side, on both sides the box has force equal to 0. Resultant force is 0, is considered to be balanced force. Alright, now let us move to another term, that is unbalanced force. When two forces act in the opposite direction and the resultant force is not 0, the direction of the resultant force is in the direction of larger force. Here you can see the example of unbalanced force. From left hand side, 35 Newton force is acting. From right side, 25 Newton force is acting. The resultant force is equal to 35 minus 25 equal to 10 Newton. Now, the next term is acceleration. Acceleration can be considered in two ways. Change in speed of the body in a given direction. Another way the acceleration can be considered is change in direction of motion of body moving with constant speed. Here you can see that there is a change in its direction. You see here the direction of motion is changing. Even if it has constant speed, there is an acceleration in the body. Now, let us recall what Newton's first law of motion is. If the resultant force acting on a body is 0, it will remain at rest or continue to move at the same speed in the same direction. Now, another situation, if the resultant force acting on a body is not 0, it will accelerate in the direction of resultant in the direction of resultant force, right? Okay, let us quickly understand. See, there are different situations where we can use the first law. Here in this situation, no force acts on the body. When the body is initially it was at rest, it will remain at rest. It will remain at rest according to first law. Box continues to be stationary on the floor. Now, let us quickly have another situation where resultant force is 0 and body was initially at rest. You see here from left hand side there is 25 Newton force acting. From right side 25 Newton force is acting. And you know the resultant force is going to be 0 in this situation. Box continues to be stationary on the floor. Now, another situation where resultant force is 0 and body was initially in motion. When resultant force is 0, body will not accelerate and it will move with constant speed in the same direction. Okay. Now let us see another situation where the resultant force is not 0 and body was moving at some speed. Due to this unbalanced, we have already understood unbalanced force. Here we see that unbalanced force, that is, a resultant force is not 0. Under this effect, what is happening? Box will start moving with greater speed in the direction of larger force. Acceleration of the box is not 0. Now, let us see this situation. The airplane is at rest on the ground. So there are two forces acting vertically. First is weight of this airplane. And there is another force acting on it, that is push of the ground. It is at rest, there is no vertical movement. It is because there is unbalanced, there is 0 resultant force acting on this airplane. Now look at this situation when airplane is in motion. In the direction of motion, there is thrust of engine acting, and in the opposite direction of its motion, there is a drag acting. Under the effect of this, we are looking at this, that airplane is in motion. It is in motion only when thrust is greater than the drag force. Now, look at the situation. What was the key learning till now? When two forces act on a body, it may be at rest, it may be moving with constant speed in the same direction. When unbalanced force acts on a body, its speed changes and it continues to move in the same direction. Its direction changes and the speed is constant. So these things we have already understood. Now let us quickly have a look. In this given situation, will the plane continue to move if the thrust and drag both are equal? Answer is no. When both the forces, thrust and drag, are equal, the resultant force is 0, and we know that when resultant force is 0, body will continue to move at constant speed or it will be at rest. Now look at another situation. Can we figure out in this question In which of the following situations is the resultant force 0? Explain how you decided. A snooker ball resting on a snooker table. A car accelerating away from traffic lights. A ball rolling along level ground and slowing down. So, out of these three situations, we can figure out that there is one case in which resultant force is 0, and that is A. A snooker ball resting on a snooker table. Now, another situation. If a boy tries to pull a crate and still it's not moving, the force which he applies is, fill in the blanks, then the friction acting between the surface and the crate. It has to be what? There's a hint. What could be the answer? Okay. So the answer is the force which he applies is less than the friction acting between the surface and the crate. So this was the important examples of Newton's first law. Now, let us move forward to learn Newton's second law. The learning outcome is recall and use of Newton's second law as force equals mass into acceleration. Force is measured in Newton, mass is measured in kilogram, acceleration is measured in meter per second squared. So let us quickly recall what is Newton's second law. According to this law, the acceleration produced in a body is directly proportional to resultant force and inversely proportional to the mass of the object. Combining these two, we can have this equation. A proportional to F, A proportional to 1 by m. Combining the two, we have the equation equals F measured in Newton equals m measured in kilogram and A measured in meter per second squared. Now, let us have a question. If two forces act on a box as shown in the diagram and the box has a mass 5 kg, calculate the acceleration of the box. Here we see there are two forces acting. From left side 35 Newton, from right side 25 Newton. Now, let us calculate this. Resultant force equals F1 minus F2, which is equal to 35 minus 25, that is equal to 10 Newton. Now, from the equation we have learned F equals m into A. We can have the equation in this manner. A equals F resultant divided by mass. So it is going to be A equals 10 divided by 5, that is equal to 2 meter per second square. This is it for the session